guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. Okay, without skipping a beat, this is Mr. Ray's SB220. Now, this thing's in really good shape, and this is owned by a Hammy. I can tell because, one, it's not all chopped up, and they don't have any markings on this thing for 10 meters anywhere on it. The top end tune they've got for 15, 20, 40. That's cute. Let's see. Yep, it's got the RF parts' capacitor in it. It's okay, they work. So in 1996, this thing had installed a soft key, a soft start, parasitic suppressor replacement, and a high voltage fuse. And at that time, 10 meters did 900 watts, 15 meters did 1,000, 20 did 1,000, 40 did 1,200, 80 meters did 1,200. And that's on 6/9 of 97. It's a good find. This thing was kept in a smoke-free environment. It's really clean. So let's slide the armor off of it and let's see what kind of work they did on the inside. Oh, this is going to be easy and fun. So when I look at this, I see a whole bunch of different little things. This has got the Harbach original soft key kit. Now they went and they drilled out. Now the one they send out now, you mount it to this nut. But they went and they drilled and they put an actual piece of nylon standoff in here to hold that up, which is pretty slick. And they did fairly clean work with this. The only thing I want to check is this capacitor here, which I'm pretty sure I'll have a good leak down on it. But the other thing I want to do is I want to go around and ground the grids. So ground out the grids. This is a good workaround for this pointless soft start. Pointless. The capacitor bank is part of the voltage circuit. This has got a doubler in it, so that does shit for Shinola. Literally. Now this operate standby switch, this might be an auto key. We will see. We will see. It's got the aftermarket Harbach suppressors on the, and then he's gone and built himself a snubbing diode here on this circuit. Now this is, well, now it's DC. So that's different. Coax doesn't look too chewed up there. This thing is in relatively very good shape. It's not a good sign. But this is the old Harbach suppression system. They don't sell these like this anymore, but yeah, I think this isn't gonna be that big of a deal. So let's flip it over and take the lid off real quick. God, somebody loved this thing very, very, very much. This is somebody's pride and joy for a lot of years. Can you believe it or not, they actually sent this thing to get serviced in 1982. Which is amazing. It means we don't have 60-year-old capacitors, we've only got 40-year-old capacitors in here, and I'm pretty sure they're going to work just fine since they're a newer model and they're not little wax caps. There's some neat stuff. This is a homebrew high voltage fuse. Look at that little guy. That's sick. The bypass cap and the blocker capacitors have been replaced. These are new Spragues. The old ones the stock ones will be red, and they have a tendency to turn into gumballs. They just absorb moisture, so if they're ever in a moisture-rich environment, they just get soft. I made a joke about that one time on a video, and then I had a guy bring me at a break a big giant tub of bubble mint gum, or double bubble gum. Big red globs of gum. It was a joke between me and him. I thought it was awesome. Personally, I thought it was hilarious. Let's see. Shield interlock system by plastic cover before servicing this unit. Okay. There's a couple other things that are done here. Like, this must have been a later model, because if we look down in here, there's no hole and the insulator board that was installed here for the Zener for bias. So this is a newer, updated board. Now they put MOVs on here. Then on top of that, they got balancing resistors that go all the way across the rectifier board. That's not normal. So somebody very meticulously took this out and did that. The glitch choke, or your glitch resistor here, this has been replaced at some point or another. But this is your bias in this board. And they've added these silver-plated pieces of copper as a heatsink. That's kind of slick. Extended the leg out in the back, too, for it to have the same thing on it. The band selector looks so original. Look down in there. Look at that. Oh, it's so clean. Meters aren't stained or discolored in any way. Somebody loved this very much. They put a towel over it every day, and they take the towel off and run it, and then they put a towel back on it. It wasn't left in the sun. We can tell that because the meters are so clear. Yeah, he knew exactly what he was doing. 80, 80, 80, and let's go talk. 40, 40, 40, let's go talk. 15 meters, 15 meters, 15, let's go talk. Man, you gotta love it. Oh, there are marks for, here's 20, 20, 20, let's go talk on it. Believe it or not, there are marks for 10 meters. It's gonna be 10 there, and 10 there. Wow, somebody loved this a lot. I love working on stuff like this. It has been very well taken care of and maintained and loved. There's guys out there that make really nice covers. The coolest guy that I've dealt with yet is he's an old CBer. His name's Bamboo. His handle's Bamboo, and he's got a really neat cover company that he started with his actual stenciled, with the sewing machine stenciled lettering. I should do a whole video on him. I bought a couple covers from him, and then I wanted to get a big one for my big box, and I said, I'll shoot you a promo ad and expose you to the radio world big time. And he just laughed. He's like, man, if you knew all the people that come along and said, you do this, you do that, you do this for me. And he goes, nah, because I'm going to need $500 for your cover. And I went, okay, I'll call you back. I never thought about it after that. I should really shoot Bamboo a video, because he makes some freaking cool stuff, man. Really high-end covers, but somebody put a cover on this and they just loved it. Sorry, I got off topic there for a minute. Well, this is what I'm going to get into tomorrow. Shoot. Do a leak down test on the cap there. I'll pull out these screws down the side and rotate this up and then disconnect the bleeders, and then I'll do a leak down test on the high voltage section. And then we'll get out the big old 220 variac, which is new. You guys haven't seen that yet. Got this big old 300-pound variac that I can sit here on a bench and I can... We'll get that running tomorrow. And we'll bring this thing up real slow with my old sloppy whore tubes. And we'll see what happens. So, on that note, it's 5 o'clock. I'm done for the day. I'm going to go sit and talk on the phone for the last hour of being open. And, yeah, more on this to come tomorrow. Bump, bump. No, sir. You have a good day. Well, thank you. Bye-bye. Phone's been busy over here today. So, what we're going to do... So, I want to show you guys how to ground the grids on these. I've been doing this... pretty steady on every SB220 coming through here for a couple of years. You can go to like Ace or Home Depot and you can get yourself, this is copper project wire. This is 100% pure copper. This is in the 16 gauge, American standard wire gauge of 16. You can use 16, 14, or 12. I see a lot of these. I had one that come in here where a guy tried to copy on how I did this and it was butchered. So what we're going to do is we're going to ground the grids over here on this socket, and it's going to look just like the grids grounding on this one. So the first thing you got to do is you got to go through and clean out all the caps. You got to take all the caps and the chokes, and somebody had been through here and they'd replaced the chokes with these resistors. Still not a fan of that. So we're going to actually ground it over. Now, this kind of affects the performance if you decide to run it at 160 meters or below, but since the tank network and the tuning network in this thing won't let you go below 80, it's really not that important. We can go ahead and ground the grids full over. For the guys that are running these on 10, 11, and 12 meters, grounding the grids is going to make everything run just as smooth as a Swiss watch. This thing is in such good condition that I'm going to do a couple other things. I'm going to come through and we're going to hand tie all of this, just like it would have been done from the factory. So we cut all the old zip ties off this thing. We're going to hand tie this thing one thing at a time. But I wanted to show the way to ground these grids, because I've seen this really butchered. I've seen guys where they try to take big, giant, flat plates of copper and put them on here. We don't want to do that. It'll hold too much heat. So what we need is just a small piece of wire that's going to easily be able to carry the 1/2 amp worth of current draw that could be maximally exposed in the most worst conditions of all potential states to that wire. Anything more than that, it's just overkill. You're just putting money in it for no reason, and it's going to hold heat in the pins. So you want to try and keep the amount of metal surface here as minimal as possible. The other thing I like to do is I like to take the old eyelets and just remove them from the cabinet completely, because we can spend all day trying to get the little hunks of wire out of these, or you can just put brand new ones in here like I do. It takes 2 seconds to put brand new ones in. Huge time saver. So first things first, we're going to take our project copper. We're going to kind of straighten it out just by lightly curling it. There's a couple different ways to get kinks out of copper. Put this around an eyelet, you know, like a screw and a workbench, and then take and fold it over a screwdriver and just draw it. And that'll straighten it out too. But since this just came off the roll, I don't think we have to do a whole awful lot to it. So I like to do is I take and I'll put a little hook in the wire. See this? There's that little tiny hook there. And what that hook affords me to do is be able to put this in the very first hole. See, now you go make a liar out of me, wire. I see how you are. Let's put a little bit more of a hook to it. Okay. So we're going to massage this down through our hole. Not too much. There we go, just right. Okay. I'm going to massage that through our hole. For aesthetic reasons only, we're going to make sure that's super straight. We're going to kind of aim it in the direction that we want to go on the socket. We're going to get on our fairly substantial hot soldering iron. I'm going to take and blob some magic pixie juice on this thing, and then we're just going to wait. And when the metal all gets to the right temperature, it'll suck it in. It'll absorb it into the pores of the metal. Just like that. We don't move it, and then you'll see it'll go shiny, and then it's going to go a dull color. So it goes dull, we can let go of it. That means the metal's re-solidified. So now we're going to come in here and we're going to bend this. And after years and years and years of doing this, I put the little crease in it, and then I can let go of it. And we got our perfect bend up on the edge of the socket tab. Heat it, wait for it to all flow together, apply a little bit of pressure, and then release. And we hold it steady, let it slowly cool down. There, now it's solid. So now what we did is we actually overused the amount of wire that we need. So let's go ahead and cut this off, just for working expediency. We're going to come back to this pin. And you see how I overbent that, how I overcorrected and then brought it back? That sharp bend allows the contact point to be maximal on that tab. Okay? So now we're going to do the same thing. We're going to overcorrect, bring it back. See how that works? It allows it to sit static. So, once again, come in here, add a little blob of solder, hold some constant pressure on it, reach out here on the edge of the wire, hold this till it's tight, let it solidify and then remove. And that's all she wrote. So now, so we don't overstress the tab or torque the tab in the wrong direction, which is really key, very key. We hold on to this with a pair of pliers, and we hook this back. And all we got to do is cut it just a little bit long. We straighten out our lead, push it back, and jiggle it up till it's through. Now you want to go through the eyelet, you guys. You don't want it just touching the eyelet. We want to go and have what they call a mechanical connection. We want to push it through the eyelet and then give it a little bit of down pressure on it. So what we're doing with that wire is we push it through the eyelet, and then in turn we're going to put a little bit of down pressure on it. Give it that little hook, just the barest amount of hook on the end of it. And that'll allow us to have a mechanical connection. So if for some reason this gets hot enough, it will never come unsoldered. The solder might fall off, but the wire will stay in place. Then the same soldering principles as before. Heat it up, apply some solder, let it flow over, and we're done. It's just as this in this circuit at this amperage rating, at this voltage rating, is what I'm debating. This is necessary in a lot of other devices. Big time. Big time. So don't misconstrue what I'm saying. Alright. Well, throw one right in here, it'll make it look pretty. And we're going to replace this output coax. God, the guys and gals that did this in World War II, their hands must have been made of steel. That's how airplane wire looms and all electronics were built, was with hand-tied systems until the zip tie was invented. I mean, personally, just because of how it looks, I like to hand tie stuff. This looks pretty to me. It shows more intimacy with the circuit. Take more time, a little bit more labor intensive, but it's prettier. Don't get me wrong, I got zip ties around here and I love them. Ooh, I use the shit out of them. Much prettier. So I could stand here all day doing this. We'll throw one back here on the wires for the fan real quick, and then we'll get on to replacing this piece of coax, which is barely even soldered down, which to me is flimsy and weak, so I can change that out. Just had a nice gentleman by the name of Steve, that's who I was talking to before I started this video here, who called. He's a longtime fan, and he wanted me to put together an official list of tools that he thinks I should recommend to him to have on his bench so he can start working on stuff like this as well. My answer to your question is like what we talked about on the phone, Steve. Good soldering iron, number one. I'm a big fan of the Weller 100 watt with the flat blade screwdriver tip, and then the Weller 100 watt with the wedge tip. Of course, then for bigger stuff, you've got to have the Weller 200 watt with the wedge tip on it. And good stands. Good coax, good amphenol ends, good screwdrivers. I prefer Klein, as everybody knows, even though everybody's got their own little favorites when it comes to screwdrivers. That's a very intimate thing for most people. The most powerful tools that I own for helping me diagnose stuff, hands down, bar none, is going to be my Fluke multimeter, my Atlas DCA 75 Pro transistor checker. But the thing that literally shaved hours off my life once I got used to using it and was worth its weight in gold when I purchased it was my FLIR. If you get used to using this and you understand a lot, you get intimate with how the parts actually work with each other, you can tell what's supposed to be hot and what's not supposed to be hot. And you can see things turning on and turning off in operation, and this saves you a lot of troubleshooting time. It allows you to skip over having to learn all the ghetto hood tactics of being able to put your fingers on stuff and understand what things are telling you if it's working or not working just by simply looking at it and going, oh, that capacitor's bad because it's not getting hot. Or, oh, that transistor's not working, it must be bad because the transistor's not getting hot in operation. So that's just a short list. Good screwdriver gun, good screwdrivers, good soldering iron, good voltmeter, good voltmeter, good voltmeter. Most important tools that you can have. So, all right, I'm going to rip this out, and I think you guys are probably done listening to me monologue. I'm going to rip this out, and when I cut back, I'll show you guys what this looks like. I'm going to pull this piece of coax out because it's literally not held in by anything. You can see this connection moving around here. Check this out. Look at this solder joint that's in here. Is that flexing? The only thing that's holding that in place is this pressure of the clamp. And we want to have an electrical connection here, that and over here. And this coax is really prone for failure. So, like I said, we'll go in here, we're going to put some RG400 in its place. And, yeah. As soon as I get that in there, now that we've grounded the grids, we're going to get out the Variac. We'll run it up on the Variac real quick, and of course then we'll just fire down on it and sit here and watch it run. We'll throw some tubes in it, check for filament light before we apply high voltage to the tubes, probe the high voltage on the other side, double check that. Then we'll put the high voltage online, and I don't think we're going to have any problems. This thing is such a clean, pristine piece of equipment, I don't think we're going to have any kind of problem. So let me get this coax changed out. We shall return. Okay. So we replaced this with this. Now, but BBI, it's the same size wire. Wrong. Yes, wrong. It's the same size wire, but the difference is this can put up with an ass-ton more heat. The main thing that causes coax to fail is the breakdown of the center dielectric insulator. Okay, this is an oil-based substance that does not hold up for shit. This neoprene in here is garbage. Okay, you really start putting some pressure on this wire, and that center conductor is going to heat up this plastic, and it's going to migrate through the plastic and short against the shield, hence causing our failure. Our RG400, though, on the other hand, has got Teflon, which has got, well, actual virgin Teflon in it, which has got a breakdown temperature of like 800 C or something plus. I think it might be 1200 C plus. So we don't have to worry about that center wire getting overly hot and migrating through the insulator out to the jacket. That, and we wanted to increase the quality of ground potential that we had here. These little tabs don't lend themselves very well to being soldered. So, those of you that want to know and those that are wanting to learn, you take a jeweler's file and you scratch this up. Just hone the outside of the metal so it's nice and shiny, and it will take a solder. So, went ahead and replaced this all the way through, and I guarantee you, and for those of you who know that watch my videos, this RG400 is some tough stuff. It's a stranded center conductor, silver, plated, hard drawn. So it's copper that they nickel plate and then they silver plate. and then it's a dual shield. Okay, so incredibly low loss, high flexibility, and it is tough as nails. I use this on some of my HF gear. My whole station is built with RG400. It's fully tonable coax. It's just mil spec. This happens. RG400 is for airplanes, by the way. They don't let you use little garbage like this in aircraft avionics. Just too prone to failure. So, okay, bottom side's done. Let's hook it up to the Variac and run it. Okay, so just moving on here. Test not shown was the capacitance leak down test, where I got out my Atlas, this guy, the ESR70, and did a load down test on the filtration circuit for the keying circuit. And then I went and I flipped the side up on this cabinet, this side, flipped it open, disconnected the bleeders, and checked each one of the capacitors. Now, we had no leakage and everything came up to the right capacitance level, but you got to perform this next test. This is really important. So what I have is my 10-to-1 reduction probe. Now, I take very good care of this. I don't use it as a prying tool. I don't use it to push and move stuff around. It gets used, wound back up, and it hangs over there where nothing can bump against it. I don't ever touch anything past this black point on the handle. This gets cleaned with acetone every once in a great while to make sure there's no oil on this probe. Anything that you take and touch to the inside of the cabinet where there's 3,000 volts present, you're trusting your life in this piece of plastic. Okay? And the only thing that's keeping you safe is this is surface area and its inability to conduct electrons, its total length and surface area. Okay? So I haven't stuck this in anything of, 10 or 12,000 volts or above. Even though it says it's rated for 40 kW, I would not use I would not put this on a 40,000 volt lead. I'd want to have a much more separation distance on 40,000 volts. I might put this on the end of a hot stick, which is a non-conducting piece of equipment that I used in the power line industry when I was working in the power line industry, and maybe touch this to 40,000 kV, but there's a difference. At 40,000 volts, there's a lot of other things you have to think about, coronal spacing, and there's some other interesting things you have to take into consideration, where this might be tested to 40 kV. I would not trust my life at 40 kV on this probe. I think about 12, maybe 15,000 volts at a very low amperage rating. Maybe. Take care of this probe. It gets laid on the bench, it gets picked up. As soon as I get done using it, I put it away. So we've got the probe at the end of the plate choke. On the high setting, 3,044 volts, 45 volts, floating. But this is the important test. Even though we did a leak down test on those capacitors, we want to double check it on this end. So now we're going to put it to the AC setting. Wait for it to count down. So 0.005, so, and floating. Now I know that means 0. And why do I know that means 0? It's just the sheer electrical potential in the air. It's 0.05. When we go directly to ground, close the loop up, 0.004, give it a second. 0.005 and floating. See what I'm saying? There's no AC ripple coming past here. There's no measurable AC current whatsoever. And that little spike that we see when we come on and off, here, check it out. Is we're measuring the actual electrostatic principle of change, the induction change between the contact of coming on, or coming off and coming on the probe point. So we got 0 AC leak, which is good. It means there's not going to be any hum. That means we're going to have a stable capacitor. Our bleeders are working very aggressively, and what I mean by that is, here's our high voltage at 3,000 volts. Low voltage at 2,500. Look at how aggressive that is. Now as we get down towards the bottom end of the scale, it's going to start moving slower, as you can see. Down to 0. Okay. With the tubes making a nice soft light as it comes on, we've got light indication here, which is off the same circuit, the same transformer. That tells us that we've got good filament. We don't have any air bottle leaks inside of our tubes. They're nice and bright. They're not dimming in any way. So now we'll bleed this down to 0. We're going to go ahead and ground out our high voltage, and then we're going to reattach our parasitics that broke off in transport because we left our anode caps on the parasitic leads, which these will not be on in return. But I'm pretty sure the only thing we're going to have to do is slide the face off of this son of a gun, and we might have to tune the input just a little bit, but we'll see. We'll see. So this is bled down to 0. Let me get my insulated grounding device, which is a big piece of virgin Teflon that's got a copper bar on it that I dug into the Teflon, and I can touch it and then touch it to the cabinet. It's about, what, 3 foot long, so I don't have to worry about killing myself. Let me get that done, and we'll attach our parasitics, and then we're going to run it. Give me just a second. Well, as you can see, we got the face off the amp now, and we're trying to adjust this slug. This is the 10-meter slug, and somebody has cracked and broke this and then put super glue in a hole. So now I got to unsolder everything that's attached to this, which is that capacitor, this lead, and this lead. And I got to pull this out, and then hopefully I've got a replacement one of these I can put in here, and we can get this thing to tune. Because right now the input tune's like 20 watts going in, it's 3 or 4 watts in input reflect, which is not acceptable. Because as we go up in drive power, we're going to have serious issues. So, yay! Give me a minute and we'll have this pulled out and we'll change it. Damn it. Wish people wouldn't do that. Let's see if we can get some light down in there to where you guys are going to be able to see this. If you can see, the thing is clearly cracked in about 3 different spots down in there, 4 different spots. And you can see where somebody dribbled super glue, because this thing's actually orientated like this. Somebody dribbled super glue in there to hold the core in place. There's this thing called beeswax, and that's what the rest of us use out here in the normal mortal world. Thank God I got extra band switches for SP220s and 201s and everything in the brotherland around here. It's kind of like I'm a repair shop. So let me file that completely unreplaceable, unobtainable band switch back out of the way here. I can't even put a price on what these things cost, these little tunable slugs. I'm sure they're out there on the internet. I've never bothered to go dig around for them, but now we've got a tunable input. Let's make sure nothing's anywhere close to the high voltage. And let's go to playing. I shall return. Okay, we now got that adjusted. Hello. 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 Call that good. Okay, so got our input unborked, got our parasitics reattached, replace the output capacitor, retied and then actually this inductor's got one extra wrap on it that it doesn't need. So if you're really brave, you could pull that inductor out, take a turn off of it, put it back in and retune it, and you'd be amazed what the input results would be. Okay, on that note, I'm going to put the face back on. Pray to God none of these wires over here break as I do the twist to flip it back around. But yeah, we're going to put this thing back together, and then we're going to run it. I think you guys are going to think it's cute what I'm going to do next. You'll see. I shall return. Okay, here we go. Your SP201 hooked up to your SP220. Now, there's going to be some guys out there freaking out right now. Oh my God, that's too much drive. No. Yes, and can be. The guy's got a 12-watt radio. So he's going to put 12 watts into his SB201, and he's going to run that into his SB220. Now, I don't know if I can make my bench radio only do 12 watts, but I want to show you the difference. So like, here's a radio, well, 20 watts of drive, right? And pardon the angle, you guys, I don't want to stick my hand over the high voltage cabinet. You know what? It's blinking at me. It says my battery's going to die. Hold on a second. It is really time to buy a new camera. Okay, so with 20 watts of drive, about 350, 375, just like what we've seen yesterday. Now let's see if I can, by killing the bench power supplies, I'm going down and running on a battery. That'll take us down to about 12 watts. Check it out. What do we learn? We're at 220 watts. Otherwise, the maximum that you can put into this. So his little President Washington that he's got, that he's going to use this thing on. Be perfect. Our input tune, of course. They normally don't come out that low. That's why I'm really proud of that, because it took a lot of time to get that going on. Okay, so step on pedal number 2. Pedal 1, pedal 2. Okay. Step on pedal 2. Look at that. 12 whole watts of drive gets us. And that's with everything on high over here, and this thing tuned out for maximum power. So we'll step on pedal 1, pedal 2, audio. It's revving that thing to the corner. So let's go to 2X. Pedal 1, pedal 2. Hi, sweetie. What's up?
Sorry, just running off to get back.
Okay, love you. Shooting video.
Okay,
Bye. Love my wonderful wife. All right, pedal 1, pedal 2. 1800 watts. Look at that. Look at our grid meter. Plate amp meter, I mean. Now, if I click it over to grid, we're under 1.5. Not overdriving it. Just saying. Okay, let's overdrive it. Alright, so let me reach down here. God, and I swear to God, if he runs it like this, he's never gonna burn anything up. He's right on the brink and top edge of what this can do. Or what this can take, and the bottom end of what this thing should safely do. So, let's step on pedal number 1. Shoot. Reach in here again and go back down to 1X. Okay. So now we brought the voltage back up on the radio. So now we're up to 20 watts of drive into amplifier 1. Little hot. About 260 watts. So now, I come back down to, or back up to 2X. Pedal 1, pedal 2. Off the scale. Okay. So we're going to go down to 5X. So now we're reading that middle scale, adding 3 zeros, or 2 zeros. 2 zeros. About 2300 watts. Exactly what it's supposed to do, fully saturated. Now I could sit here and I could twiddly dink with these a little bit more, and I'm sure I could get another 100 watts out of it. But what's the point? Mr. Ray, bro, you're done. These 2 units work perfectly now. Spot on, perfection. From the man that's got a soldering iron put on his arm. Yes, sir. I'm excited. So now all I got to do is pack both these things in the house, get shipping quotes after I put, well, I got to let the tubes cool off. Pull my tubes out, put your anode caps on the inside of this thing, put the lid back on it, put the armor on it, and then pack it in the house, get a shipping quote, and give you a call. It's a beautiful thing. I love working on these, but it takes me forever to get around to being able to do them. I mean, I love working on Heathkit stuff. It's simple, it's easy, it's very basic. Yes, it does require a great amount of time to disassemble everything and reassemble it. I went ahead, Ray, and I re-indexed all your knobs, by the way. That's on 10. That's on 10. You want to start out on 10 and then just tune it in for maximum performance. So everything works. Your grid, your relative power, everything on this works. Your sensitivity knob works. Everything works good. I went ahead and I took the fan and I dropped it down by 2 slots in the back, 2 little holes. You can't tell it, but it drops the fan down by about that much. And by doing that, it increases the airflow across the bottom side of the tubes, so you get better cooling on the pins. It doesn't help a lot, but it helps a little, and every little bit you get can add up to something big. So, fully restored SB201 that you guys can see in part 1, and fully tested, checked, and tuned for the way it's going to be used, SB220. Gentlemen, my name is BBI. No, wait a minute. Oh. Let me slide out here. Got to get a picture. Gentlemen, my name is BBI. And without a shadow of a doubt, click. I'm the biggest mud duck in Idaho. Come check me out, www.bbiamps.com. And as always, if you like what you've seen, click subscribe so you can follow along. And if you've enjoyed this video, just give me a thumbs up. Makes both of us feel better. All right, guys, I got to go. I got a couple hours in the editing booth to make all this look like some homogeneous train of thought, even though that's not the way my brain works. So I got to get. We'll see ya. Thank you, Mr. Ray. I appreciate your patience, buddy.